Hello students, let me start. So I'm resuming on the explanation about income and substitution effect, right? And let me take this one. So we have three different baskets, as in the last class, basket A, B, and C, right? For basket A, it is driven under the price of good X is $9, right? So at the beginning, the price of food, which is good X, was 9, but it drops from 9 to 4, right? As it does, our budget line was this one at the beginning, but now it changed to this one, right? So originally optimal basket was at A, but after the price of good X falls to 4, the new optimal basket occurs at C, right? And the slope of budget line at the beginning was minus 9. That was px divided by py1. What about here? px4 now divided by the same price of good y, which is 1, and with negative sign, right? So this is budget line 2, this is budget line 1. Another hypothetical one we made that the way we made, we keep the original indifference curve, right? Now we ignore original budget line. Instead of that, we introduce new kind of budget line with the slope of new good price, which is fallen one from 9 to 4, right? So we know at least the slope of new budget line. We don't fix the location yet. But the way we fix the location, we want to find a tangent with the original indifference. That happens at B, right? So that's this B. And the way we do, take this indifference curve, right? How did I derive this number? Using basket A, which is 4 and 36, right? Plug 4 for X, plug 36 for Y, right? Multiplication between these two numbers gives 144. That's utility level, which is U1, and which become indifference curve, right? So taking this one and another one, we are using this one. MLS equal to new price ratio, right? From this one here, minus 4, because we are taking a minus sign, right? So using these two equations, we draw new basket B, which the coordinate 6 for X, 24 for Y, right? And actually, we can derive this one. Just taking this budget line and taking this tangent condition, right? This budget line is like this, 4x plus y equal original income, that's 74. So solving these two equations, right? For x and y, we derive C, which the coordinate of it 9 and 36, right? That's it. And here, we define substitution effect is kind of substitution along original indifference curve by the difference of what? Relative price ratio. So we trace on original budget line. Only the change is the slope of budget line, thus tangent point, right? So substitution effect says as the price of good X first, right? We substitute Y for more X. We spend more on X, even though there is no change in utility level due to only decrease in the price of good X, right? Once we reach here, the difference between B and C, there is no more change in relative price level, only income level, right? So this one, right? For this one, what I guess 4x plus y is something less than 74, right? If we go back to previous one, I believe might be, I would using b. b is 6 and 24, right? So this is gonna be 48, right? That's 48, I think so. So this one should be 48, I believe, because the price of good y is 1. 48 divided 1 will become 48. The same thing for this one. 72 divided by 1 will be 72. Here 72, right? And changing from A to C, which correspond from 4 to 9, the 5, right? Out of 5, 2 we categorize as substitution effect. The remainder 3, we categorize that as income effect. If you think about income consumption path at the beginning of this class, you will see this is kind of income consumption path. Using this one, we can derive what? Good X and income, that's angle curve, right? What about good X and price of good X? We can derive demand curve from what? Price consumption curve. You can go back to the material at the beginning of this section, right? So this is about substitution and income effect, right? Now let me move to the next slide. Before I do that, I may consider one more thing, right? Now, instead of taking this original indifference curve, now taking new indifference curve, right? And taking this one and assuming price ratio went back to the original one, 9. So we can find a new tangent here, right? We denote that basket as E. At E, we can derive what? The income level required to support this budget line. How can you do so? We know that one 9x plus y. We don't know the income level. But once we draw point E, right, the basket E has certain number of x and y. We plug that into this one. And then we can find out. I guess so. I believe it should be 104. This will be 54. What about 69? Right. This should be 6 and 45. At basket E, the coordinate 6 and 54. So the income will be 108. And then we measure the difference between these two curves. What I'm saying, these two curves, budget line, have same slope, same price ratio. Only the income level are different. And also gap between these two curves, right? The new budget line slope, right? For this one. And what he derived here, this is 72. This is how much? I believe 48. This is 108. Then this distance for these two budget lines will become 24. What about this one? 24 plus 8 gonna be 36. What I can find out, for this one, we call compensating variation. We call this one equivalent variation. Here, equivalent variation become greater than compensating variation. That's the concept we did in the last section. So you need to go over this one once again. And the reason equivalent variation becomes bigger than compensating variation is because the price for good X here for equivalent variation is greater than the price of good X applied for compensating variation. Here, price of good X, we choose the fallen one, but there we use the original one, which is expensive, 9. That's the reason why I can give it to you. So here, now let me read the sentence I've written down here, right? Substitution and income effect once again. As the price of good X first, all else constant doesn't change, good X become cheaper relative to good Y. This change in relative price from 9 to 4, right? 9 over 1, 4 over 1. This change in price alone, caused the consumer to adjust their consumption basket. We call it substitution effect, right? From here, was here A, but we reach B along the same indifference curve. We call that substitution effect. And the substitution effect is always negative, meaning the changing direction is opposite, right? Price of good X first, but as a result, consumption amount on good X increase from A to B. X increase, Y first, right? So that's what I mean, always negative. By the way, a move along the demand curve will be composed of both effects, substitution and income effect. Income effect change from B to C, right? Changing from B to C, we further increase consumption of good X, right? And as a result, let's say this is a demand curve, right? Every point along the demand curve, utility is maximized, given constraint, which is a budget set, right? This is PX, this is amount of good X, right? As the price of good X first, we move from basket A to basket C. But we find out there is another basket. Just looking at substitution effect is right here. As the price of good X first from 9 to 4, right? The amount of good X increase, right? I forgot this one. Was it 4 to 9? I'm not sure. Let's say that way, 6, right? For B, 2 more increase in the consumption of good X, and income effect further expedite the increase in the consumption of good X by 3 more, right? So if we only consider substitution effect, demand curve becomes steeper than this one, right? But as well as substitution effect, income effect is added, thus the demand function become much flatter than the demand function if it only reflects what? Substitution effect. That's what that sentence is saying. Let me go back to there. Right. By the way, move along the demand curve will be composed of both effects, which is substitution and income effect. So if we ignore income effect, the demand curve become much flatter than steeper than before. Let me speak in Korean. 자, 이게 사실은 내 기억으로는 내가 대학교 졸업하고 입사 시험 같은 데 많이 나왔던 것 같아요. 원래 디맨드 커브가 이렇게 있다면 그거는 뭐예요? 인컴 이펙트를 보지 않은 A부터 C까지가 아니라 A부터 B까지만 반영한 substitution 이펙트만 있는 게 있고, 거기 인컴 이펙트로 X가 더 늘었잖아. PX가 여기서부터 일로 떨어진다고 할 때. 그렇죠? 그렇죠? 그래서 인컴 이펙트가 없다면 디맨드 커브는 더 뭐예요? 가팔라진다, 가팔라지지 않는다? 더 가팔라진다. 더 가팔라질수록 프라이스 일러스트레이브 디맨드는 어떻게 커져요? 떨어져요? 프라이스 오브 일러스트레이브 디맨드가 플랫에 가까울수록 큰 거니까 더 줄어들죠. 그쵸? 그러면 탄력적이 되는데 이유는 substitution 이펙트와 더불어서 인컴 이펙트도 동시에 기여를 하는 겁니다. 알겠습니까? 이런 지문이 아마 시험 문제 종종 나올 거예요. 객관식에서. 제가 낸 게 아니라 그렇다는 거예요. Now, let me read the second one. As the price of good X first, all else constant, purchasing power rise. This is called the income effect due to a change in the price. What does that mean? What I mean, we was at A at the beginning, right? But as the price of good X first, my budget had expanded like this one. It was here, but now the size of triangle increase. And substitution effect says just moving along original indifference curve with the new price ratio should be this B, right? But now we can see income effect arise, income consumption curve, right? And this compensating variation, we draw that's 24, that's corresponding this one, purchasing power rise. Like we have additional $24 as an income, right? So this compensating variation exactly same as purchasing, the magnitude of rise in purchasing power, right? And we call this as income effect. So I'm relating compensating variation to income effect due to a fallen price in good X, right? The income effect is positive for normal good, right? As your income increase, right, the price ratio is the same, but as your budget set shifting outward, right, you're spending on good X. If that increase, then this income effect is positive and good X is categorized as normal good. And it could be otherwise. I mean, in some case otherwise. Your consumption could be negative. Then we call this as inferior good, right? And for 3, the extreme case of inferior good, if a good is so much inferior that the net effect of price decrease of good X lead to a decrease in the consumption of good X finally, then the good X is categorized, we call 기펜good. In Korean, 열등제의 극단적인 경우가 기펜제라고 얘기하는 거예요. 그리고 기펜제면 어떻게 되냐면 law of demand가 breakdown 됩니다. 자, law of demand라는 게 뭐냐면 px x가 뭐예요? downward sloping curve죠. 그 law of demand인데 이게 breakdown 된다는 건 뭐야? upward sloping이 된다는 거죠. 이렇게 된다는 겁니다. 이렇게. 저 위부터 그렇다는 게 아니라 어느 정도 가다 확 꺾여서 이걸 backward bending이라고도 우리가 해요. 이렇다는 겁니다. 그래서 if good is so inferior, the net effect of price decrease of good X, right, lead to a decrease in the consumption of good X. Here, the consumption amount is increasing as price falls, right? But there, even though price is falling, right, the amount of good consumption for good X is falling instead of increasing, right here. If that happens, we call this good is given good, right? We will see in the next picture much more in detail. Right, this one. So given good definition, when a price falls, it always lead, if it was not, an ordinary case, lead to more consumption through its substitution effect, right? Substitution effect says when price falls, consume more of that good because it becomes cheaper. That's the substitution effect says. If it becomes cheaper, consume more. If it becomes relatively expensive, consume less, right? On the other hand, the falling price also increases purchasing power, right? Shift from A to B is consumption effect. Substitution effect, right? And from B to C, always income effect, right? So falling price increase what? Your purchasing power by compensating variation. Increase purchasing power. However, if the good were so inferior, right, and the intensity is too huge, so that this inferior good effect dominates substitution effect, then the final direction of consumption may decrease. It is given good. For the demand curve, given good, we can see backward bending there. And what about this price consumption curve? So this is like price consumption curve. As price first, it was your original budget 9. New one will be here. Right? Oh, this is not exactly given good. But if we perfectly fit for given good, tangents happens here. Does it make sense? Originally, I choose A. Due to the decrease in the price of good X, my budget set expanded, right? And the falling good price, substitution effect says consume more of good X, always, right? as long as your indifference curve is bowed inward, right? Diminishing MLS, always substitution effect, says spend more on the good whose price become relatively cheaper, right? But there is other thing. Income effect works as inferior good. This is the case, right? At C, your final consumption on good X becomes smaller than at basket B. So at C, I can say this is inferior good. But if that extent, the intensity of inferior good become too huge, if the tangents happened here at point, let's say D, right? The amount of good purchased at basket D become lower than the original amount of good X. Then we call that given good, right? And if that's true, even for demand curve shows backward bending, then let me check your understanding. If a certain good is given, then it's inferior good. Is that right one or wrong one? This is the correct one. Another one, if the good is inferior, then it is given. Is it right or wrong? That's a wrong one, right? Check your understanding once again, based upon this sentence I suggest to you. Now let me go over once again compensating variation. Compensating variation is about this KL segment, right? Relative to this one, how do I say JK, right? KL. JK, the magnitude of JK line correspond to equivalent variation. Now let's read the definition of compensating variation and the definition of equivalent variation. By the way, the Korean wording for compensating variation is 보상 변화, right? Korean wording for equivalent variation is 대등 변화. Let me speak in Korean. 여러분, compensating variation을 해석해 보세요. variation 변화, compensating, compensate, compensation, 보상밖에 안 될 것 같죠? equivalent variation은 이거 어떻게 equivalent니까 같다, 등식, 대등 variation 이거. 자, 제가 여기다 저도 헷갈려 써놓은 거예요. compensating variation은 변화된 가격에서 보는 거고 equivalent variation은 종전 가격이다라고 했는데, 자, 이 두 선은 종전 가격이에요? 종전 가격이죠. 그러면 또 바꿔서 이 두 선은 변화된 가격이에요? 변화된 가격이죠. 그래서 이 KL, 이 디스턴스는 뭐예요? 보상 변화, 변화된 가격. 그 다음에 이 대등 변화는 종전 가격하에서 JK, equivalent variation. 제가 한번 얘기했을 텐데 왜 equivalent variation이 더 크죠? equivalent variation에 적용되는 price of good X는 9이고 보상 변화에 적용되는 건 4여서 9이 더 크기 때문에 한 유닛을 X를 쓰더라도 유닛당 프라이스가 어때요? 더 많이 드니까 그거를 우리가 소비하게 해줄 수 있는 인컴은 어떻게 돼야 돼? 더 커야지. 그래서 그렇습니다. 자, now let me read the definition for compensating variation first. A measure of how much money a consumer is willing to give up after a change in price. Condition for that to be just as well as before the price change. So before the price change. Before the price change, right? Before the price change, he was here, right? And actually, the key thing is in different level. It's this one. His utilities here. Might be, was it 144? I'm not sure. Let's suppose that is true, right? That's the, before the change of the price good X, he was A. Now, after the price change, instead of A, he can pick B and enjoy the same utility. But at basket B, if the price of good X first, the income to achieve basket B is much smaller than before. It was 72, but now it become 48. So, to make him just as well as before the price change, so at the price of 9 for good X, to make him just as well as before, right? How much money consumer willing to sacrifice? He is willing to sacrifice. The gap between these two will be 24. If we make the price of good X fall to 9 to 4, then for that, I'm ready to give up $24. That's the compensating variation. Let me read the Korean wording here. 새 가격에서 4달러에서 종전의 효용 144를 보전해 주기 위해 내가 소득 중 얼마를 포기할 생각이 있다. 가격 X가 떨어져서 하나가 굿 사이드니까 배드 사이드로 난 인컴을 얼마큼 너한테 다시 기부업해서 나는 똑같은 수준 A 대신 B지만 유지할 수 있다. 그때 내가 내놓을 수 있는 소득이 얼마냐? 24불이다. 그러면 정부가 이렇게 할 수 있는 거지. 24불을 여러분한테 더 주는 게 나을까? 가격 보조를 해서 XJ 가격을 9에서 4로 떨어뜨려 주는 게 좋을까? 이런 문제도 있어요. 여러분의 생필품의 가격을 떨어뜨려 준 대신 소득을 안 주거나 아니면 소득을 주는 대신 생필품의 가격을 그대로 유지시키는 정책 중에 어느 걸 택하는 게 맞느냐라는 퀘스천이 이것 때문에 나옵니다. 사실은 지금 국민재단 소득을 저희가 코로나 때문에 주는데 그걸 주느냐 아니면 여러분이 많이 쓰는 생필품의 어떤 가격을 떨어뜨리느냐. 여러분 생각에 뭐가 나아요? 소득을 주는 게 낫겠죠. 그렇죠? 하지만 경우에 따라서 어떤 특정 재화의 가격을 떨어뜨리는 걸로 재난 기본소득을 주는 대신에 정부가 국민을 보조해 줄 수도 있다는 겁니다. 알겠습니까? Now, let me go over with the second concept, equivalent variation. Korean wording is 대등변화. A measure of how much money a consumer willing to receive to be as well as after the price change. After the price change, right? After the price change, he reached SC. SC, his utility level is U2, right? Let me erase the writing, right? SC, right? His utility clearly increased from U1 to U2, right? And now let me ask, if I make you feel the same as U2, but I want to bring the price of good X to the original one, the expensive one, right? At this price, original price, to make you achieve this U2, new utility, how much income do I have to give you more? That's the question, right? This one. It was 108, it was 72, the gap, I believe, is 36. So that's the equivalent variation. Let me read once again. A measure of how much money a consumer need to want to receive to be as well as after the price change. After the price change, he achieved this one, but at the new price. Original price, I'm sorry. The extent of income variation required in order to shift from original utility level to a new level at old price, right? That's about equivalent variation. Now let me move on to the next slide. So here, right, you can see this slide, another one. I will not go over this one. This is nothing more than another example of computing compensating variation, equivalent variation. The change I made utility function and your income level. The price ratio still the same, 9 and 1. And I just dropped the price of good X to 4, right? You can do all the exercise, find out basket A, C, and decompose basket B, and find out new E for equivalent variation and compute the utility level at each basket, right? And find out for basket compensating variation, find out equivalent variation at new basket E, right? And you can do the exercise following the writing I made here for these two pages. This is for your homework and this is for your final exam. I think so. You should do it on your own, not depending on what your friends has done. So now I'm moving to this one. Let me take a 1 second break and I can come back. Oh, not this one. I'm sorry, let me resume on this slide, right? So we want to find out the optimal basket, and it happens the optimal basket occur with a corner point here, right? That's why we are going over this slide. Here, our utility function looks pretty much weird. Up to here, pretty much same as before, but we have additional term, right? It looks weird, but the basic method to derive the optimal basket is same as before. What is it? MRS equal the price ratio. What composed of MRS? Marginal utility of X over marginal utility of Y, right? What's the marginal utility of X? You need to take the differentiation with respect to X. So for this one, Y will be driven. What about this one? Will be 10. So that's gonna be marginal utility of good X. What about marginal utility of good Y? Take the differentiation, hold this term with respect to Y. This doesn't have any Y, so this is constant. So after differentiation, the value becomes 0. What about here? The X will become marginal utility of Y. So 10y plus 10 over X here will become MRS. And set MRS, set that equal to price ratio, right? So we derived one equation. We are going to solve for X and Y, 2 now. So we need one more equation right here, the budget set. So we have 2 equations. That's enough to find out optimal solution for X and Y. First, let's derive the Y. So check whether this is correct or not. How can you do so? So from here, right, we can make px times y. So this is y plus 10 over x equal this one. So what I'm saying, multiply both sides by x, right, by x. Then x, this one will disappear, and multiply both sides by py. So right hand side become px times x. So out of this budget line, we can replace out this px times x term by this one. So we plug that one here. So y plus 10 py replace out px times x plus py times y equal I. Now we factoring out py times y term. We have another one is here, right? So we have 2 py times y plus, what about this one? 10 times py equal I. Now subtract this one from both sides. So 2 py times y equal I minus 10 py. And divide both sides by 2 py. So it becomes demand for good y right here. Now, I said in some previous lecture, our solution is located on from 4 quadrant, just first quadrant, meaning x and y should be greater than 0 or equal to 0. Equal to 0 is a corner solution. To do so, this one should be greater than 0. Price is always positive, so denominator is always positive. The remaining questioning part to us, the numerator. I minus 10 py should be greater than 0. Means what? Switch this one to the right hand side. And that's it, right? As long as income is greater than 10 py, right? The value of y is positive. But there are other cases. I mean, otherwise mean it could be this way, right? So I is less than 10 pi. When it happens, if the price of good Y goes up too much, if the price of good X become too expensive, that's what this one. What if that happens? Then we may have this as minus, right? Rather than having minus, we just make the value of Y is 0, is there. X-axis represent the value of Y is 0. What about Y-axis? The value of X is 0. So we want to find here as optimal basket, that's the corner basket, right? What's the characteristic of a corner solution? Let's think about this one. What about this one? So this is indifference curve. Let's say, is this one correct? So slope of MLS at point A, let's say this is A, in absolute value, greater than the slope of budget line. So importance of good X in terms of good Y for this consumer is higher than the evaluation from the market, right? Then this consumer want to consume more of good X, right? But the problem is affordability. After this corner point, this indifference curve become unaffordable. Doesn't have any place touch on this affordability, right? So we ended up at A, which is a corner solution, and the characteristic at A, Y becomes 0. Versus this one, I suggest you another one. What about this case? If the indifference curve shows this way. Point A will be supported as corner? No, I don't think so. Why? The importance of good X, right? At A, you only consume X. You love X too much, right? Like this one. But here, your preference for good X in terms of Y, which is lower than what market value. Then what are you gonna do? You wanna sacrifice X, right? And for that, sacrifice X will give you more Y. So you wanna shift this way. Until where? Until you reach B. Right? At this corner, right? Who value X more? Right? The market, the slope of the market is steeper than the slope of you at B, the consumer. Right? So market value X more than what you value. So you don't want X, or you want X less than what market wants. That's why you end up B. At B, your consumption amount of good X becomes 0. Right? That's what it is. So at a corner solution, what I'm saying, the absolute value of MLS, which is decomposed mu of X over mu of Y, should be greater than the price ratio. Right? We need to check whether that is whole. Right? So what's the MRS? Is this one, as we driven here, and the price ratio, whether that is correct here. That's what I'm asking. At this point, by the way, the value of Y become 0, right? Because the point is lying on x-axis. So we plug 0 into Y. Then after that, 10 over x is greater than px over py. Right? And what I can do so. Also, what about amount of px? If you are consuming only good x, how many units you can consume here? I divided by px. Divided by px. Right? And plug that for x. I divided by px. And if you solve this one, it became 10 px divided by I, because denominator in denominator become numerator, become px times, that's greater than px over py. And we can find the same px for both sides. So cancel it out and multiply both sides by I. 10 is I over py. Multiply both sides by py once again. Then 10 py is greater than I. Right. That's a condition for this corner. Right. But have you seen this one before somewhere? Right here. The change the place. Right. So we simply find out condition already. Right. And the meaning of this condition says MRS is bigger than price ratio. Right, that's what I'm saying. And let me move on to the next slide. Supplementary for a corner point. What is this one? So having this one as a corner, the slope of MRS should be greater than the slope of budget line. This is budget line. Supporting corner along y-axis, slope of MRS should be in absolute value less than slope of budget line. That's what it says. And the characteristic here, right? The slope of budget line here compared to this one is steeper, meaning absolute value of the slope is this one. Becoming this one steeper, meaning px should be greater. It means px become more expensive. What about here? The slope of budget line is flatter. Flatter one, this one is going down, total one. To do so, price of good x become expensive. Then as the denominator, the value of denominator becomes greater, right? The greater the value of denominator, total value of the slope become smaller. So we require expensive py. As py become expensive, your choice on y becomes 0. What about here? As the price of good x become expensive, your choice on good x becomes 0. Right? You spend all the money entirely on good y. I divided by py. What about here? I divided by px, meaning you didn't spend any money on good y. You spent entire money on good x. And this is the maximum amount you can purchase for good x. Right? Now, I'm thinking I want to go over this one, but considering the time limit, I think I'd better stop here for today's lecture. And let me start from this slide on coming Thursday. And I wish you have a nice weekday.